Hi there, welcome to question 2. Just a reminder, this is on 2A, 2B, 2C. I keep saying, and I need to stop doing it. Tell my class off for that. We've got 5 parts to this question. You need to use the preliminary material. I'm going to try and not do too much writing or formal writing for this first part. So use the electricity generation from the preliminary material. The bar chart shows how each of the 4 nations of the United Kingdom generated electricity in 2019. Did it again. I need to get comfortable with the pause. That's what my YouTuber who I follow says. We have these 4 bars, Scotland, Wales, Northern Ireland, and England, suggest 2 improvements that can be made to the bar chart. So the first thing is, right, when I looked at that, having done Unit 1, you think of it as national insurance. So perhaps they need to spell out Northern Ireland. Because if you were, say, from somewhere in Europe and you weren't particularly familiar with all these countries, that would be something that would potentially hold you back from analysing this data. There's no title, so we could add a title to this. We could show amounts, so show amounts and not percentages. Although these guys are trying to show who's showing the highest proportion of renewables. We could label the axes. We could include values on the charts. And also grid lines would be really useful because actually we can't tell what that value is, So some grid lines would massively help that. Also add another bar for average. So what effectively these questions are asking you to do is to just improve the graph. There will always be some things to improve, and the silliest answers can get you marks. Don't leave this question without writing something. However, what you cannot put make the X or Y axes bigger. You cannot make a larger scale. You cannot put a separate bar chart for each country. You cannot use color. You cannot put different type of chart. So those answers are just too vague, too generic. So it needs to be specific to this actual diagram that we have. Okay, so that's 2A. 2B. I did it again. That's my filler word, isn't it? 2B. We've got the morning record suggesting that electricity generated by renewables reached more than 70% of that generated from fossil fuels. So we go into the table, into the preliminary material, and take those values from it. So we've got fossil fuels, which were 110221, and we've got renewables, which was 78105. By dividing the renewables by the fossil fuels and then multiplying it by 100, we get the percentage because it says more than 70% of that generated of fossil fuels. So fossil fuels becomes the denominator. That is 70.86%. And because we've got that very important value, we can just write valid claim and confirm that the morning record is correct. For the daily bulletin, I was not happy with this because the mark scheme doesn't have my method in it, and my method works. So we've got 33791, and we've got 44314, and we need to see if it works from 13 to 17. I suppose we could do it. Can we do it this way? I'll do it a different way, just for fun. 33791 divided by 13, 44314 divided by 17, because if we're going to divide by the same thing, we should get a similar answer to these 2 calculations. My method was much better, but here's what it is. Oh, hold on. Where did the 44314 come from? Right, sorry. So all of them add up to 78105, and if you subtract the wind from it, you get 44314, and that's where it's come from. So we've got wind and everything else. Everything else has been calculated by the total, take away that value for the wind. Okay, 33791 divided by 13, that gives us 2599.31. 44314 divided by 17 gives us 2606.71. And it's that bit there. It's about 13.17. So as 2599.31 and 2606.71 are close, the ratio is about 13 to 17. I know the mark scheme won't have those exact things in it, but if you're making sense to your examiner, they will be more than happy to give you full credit. And that's 5 marks. That's a big 5 mark at that. 2C. Very numerical. This. Going to write a lot of zeros. So the average cost of electricity, 14.4 pence per kilowatt hour. And there's 1 million of them in a gigawatt hour. Brilliant. Northern Ireland generated 4,189 gigawatt hours. Anna says in 2019, Northern Ireland generated electricity by renewables worth over £600 million. Is she correct? Thanks, Anna, for making me fact check you. Brilliant. So 14.4 times by 1 million gives me 14,400,000 pence. And that's 1 gigawatt hour. Now, if we convert that into pounds, we get 144,000. Then this value is going to be multiplied by 4,189, which gives us £603,216,000, which is roughly 603 million. So yes, correct. Thank you, Anna. Well done. Part D. Wales generated 7,700 gigawatt hours of electricity by renewables. Work out the total amount of electricity generated in Wales from all fuels. Now, the 7,700 equals 26.9% when we look at the preliminary material. Okay, let's get that preliminary material out and have a little look at it. Yep, we've got the table. It's on chart 1, and you're looking at chart 1, renewable share of generation is the y-axis label, and Wales has got 26.9. Therefore, if we divide our value by 26.9, that tells us what 1% is, and then we multiply it by 100, that will give us the full amount, which is 28,624.53532. And we can round that to 28,625 gigawatt hours. 2 more marks in the bag. Okay. Another mark for a bit more critical analysis. I've got 3 bullet points here. So the amount produced per country is not the same. So this guy, Bobby, has basically wanted to find out the average across all 4, and he's found the average of the averages, and that doesn't always work. Therefore, his calculations are wrong. We need to critical analyse it, and we've just said the amount produced per country is not the same, and we need to know the actual figures, add them all together, and then work out the average. We could also say, should have worked out the total energy generated by renewables, which is kind of a similar answer. And then the mean percentage is based on each country's total, not the whole. So the mean percentage is on each country, but not the UK as a whole. And that's really important for you to understand, that you can't work out the mean of a mean and say that is the total average. You have to go back to your raw data, find the values, and then calculate it from there. That's question 2 done. As I said, this will go into 2A, 2B, and 2C's playlist. And I'll see you for question 3 on whatever paper you're currently working on. See you next time. Bye-bye.